Hi, I'm Lauren Paulson, and this is Lab 5, Choose Your Own Adventure. I decided to look at how to determine the max component of static friction from using an inclined plane. So, an introduction, my experiment involved the max inclined angle at which an object moves. From this we can calculate the max component of static friction. The physics principles we are going to use is force, gravity, friction, free body diagrams, and inclines. This is the equations I used to get my calculations. So for the data, I did an experiment where I put this book on this surface and angled it until the book slipped, as we can see in this video. In the video we see the book starts to slip at 31 degrees. Then I also got the mass of the book, which was about 0.6 kilograms, and from the incline angle of 31 degrees and this component of static friction, using that incline angle of 31 degrees, I calculated using these equations I showed in the introduction. Then I modeled this experiment in GlowScript. Let me show you that. So I did normal visualization, which we've done in a lot of the labs. I put the ball's mass as the mass I demonstrate the book as a ball. I put the mass as the mass I measured. We start at 0 degrees. I put the static friction we calculated, and gravity as 9.8. We start with a position and velocity of 0 because it's not moving. We start at time 0, delta t of 0.01 each time. Then for 3 seconds we run this loop, and it will keep the book not moving until the gravitational force in the x direction is greater than the max static friction. So it runs that, and I will show you how that runs. And it increases the angle each time. So we see we're not moving, and then we start to move as it angles more. So it prints out the time, the angle, and the acceleration. So when our book starts moving will be as soon as the acceleration starts being 0, which we can see is very close to 31 as we got in our real life lab, which is really good. Then some questions about this lab. What if the mass increased and static friction stayed the same? So the component of static friction stays the same, but the mass increases. Now, actually, nothing would change in our experiment. Since our equation that we use to get the static friction and angle, mass and gravity actually cancel out on both sides. So the components of mass and gravity don't impact the experiment, and our only determining factor is the component of static friction and the angle. And we can actually see this in our GlowScript model if I edit this mass, and let's make it a very large mass, and it still will show an incline angle where it slips of about 31 degrees. If we go and we look here, same data, still about 31 degrees. Now, what if static friction was increased? If static friction, the component of static friction was increased, the angle at which the book slips would increase, because once we cancel out mass and gravity, we get this equation. So the component of static friction is equal to the tangent of the angle, meaning as static friction increases, the tangent of the angle increases, meaning the angle itself would have to increase. And we can see this again if we make a larger component of static friction and run this. We can see it stays still and then starts moving, and if we look at the angle it starts moving at about 38.5 or so degrees now instead of 31, and that is because we have a larger component of static friction. I hope my lab was able to teach you something and you were able to enjoy it and can hopefully apply these in your own life when you need to find out what static friction is. Thank you.